Okay, let's see how you can use differentiation to find the stationary or turning point of a quadratic graph. So, for example, when you have a quadratic graph like so, this is a turning point. This is a turning point too. So, stationary and turning points, they have a tangent. It's basically a straight line. It's where it turns. It's the turning point. So this means that at these points, m is going to equal 0. The gradient will always be 0 at stationary and turning points. We can use this to our advantage. Therefore, to find a turning point, you can differentiate the equation that you've provided, equate it to 0 because the gradient will be 0, and then just solve for x. Then you can input x into your original equation to find the y point and the xy coordinates in order to find the turning points of your question. And you'll also be asked to classify their nature. Classify the nature of the turning point, whether it's a maximum or a minimum turning point. So when you have a quadratic like this is going to be the minimum turning point. This will be the maximum turning point, the tallest, the lowest points. We'll explain exactly how this works as we look through a past paper question. Okay, find and classify the turning points on the curve for y equals 2x cubed minus 15x squared plus 24x plus 3. So we want to find and classify the turning points on the curve. That's the question. First of all, we need the gradient, so let's do dy dx. We're not going to do f dash of x because this time it's not a function, it's just dy dx. It's a y equals something. 2 times 3 is 6x squared minus 30x plus 24, right? That's the differentiated equation. That's going to equal 0 because it's a turning point, 0. Then we can now factorize this. First of all, let's simplify this. We can divide both sides by 6. That'll give us x squared minus 5x plus 4. 0 divided by 0 is just 0 still. Factorizing this quadratic, what numbers multiply to make 4 and add to make negative 5? Well, negative 4 and negative 1 multiply to make 4 and add to make negative 5. That's the equation factorized. And so the values of x are either x equals 4 and x equals 1, right? There's one issue. We need to classify the nature of this, right? First of all, let's find the y coordinates. We're supposed to find the turning points, not just the x values, the y coordinates too. So we're going to input these two coordinates that we found, x equals 4 and x equals 1. These are the turning points. Back into, let me write that a bit better, our original equation. The mistake that many students make is inputting this into your dy dx equation, which is just the equation for gradient, not for your turning points. So if we input x equals 4 back into our equation and sub in x equals 4, we find that y equals, to save you the work, y equals minus 13. And if we input 1 into the equation, we find that y equals 14. So the 2 points are 4, negative 13, and 1, 14. Now I just skipped through the process of substituting in the x and y values because I'm sure you can easily do that. Just sub in 4 for everywhere there's x and just solve. That'll give us minus 13 and 14, and these are the respective coordinates, right? How do you classify these 2 points? So these two are the turning points, so it's like points like these. But how do you know which one is the maximum point and which one is the minimum turning point? If we draw a rough sketch of a graph, we can see 4 minus 13 would be somewhere around here, right? 1 and 14 would be somewhere around, where would 1 and 14 be? Somewhere around here, right? If it's a curve, it's going to be going somewhere like this. Sorry about that. It's a curve. It would be turning here and then turning again like this. Because there's a point above it, it's not going to be turning point of this and going downwards like that. No, because we have another point here. So this is one turning point and this is another turning point. Because this one is higher, 114, this will be classified as the maximum turning point. And because this one is lower, this will be the lower turning point. Let's look at just one more example and then we'll end. So we want to find This is the way the questions will be asked. Find and classify the turning point. The turning point, it could be points as well. For this one's a bit easier actually. Y equals 2x squared minus 4x plus 7. Because it's not a cubic, cubic is like this. Cubic has multiple roots, right? Roots where it crosses, so it's going to have 2 turning points. Because it's just x squared, it's just going to be 1 turning point, which makes our life a lot more easier. Let's find dy dx for the gradient. 2 times 2, 4x minus 4, that's our dy dx. And yeah, 4x minus 4. And we can equate that to 0 because it's a turning point. When it's turning, the gradient is 0. That means 4x is equal to 4. We can add 4 on both sides to simplify that, and x is going to be 1. When x is 1, what would y be? We're going to sub that back in, not to our dy dx, but into our original equation. So 2 times 1 minus 4 plus 7, that gives us 5. Yep. 1, 5 is the coordinates of the turning point. So if you look here, we have 1, and it's going to be way up here, 1, 5. Right? But now you come across an issue. I specifically chose this for a reason. Because we don't have 2 turning points, right? We don't know if this one is the maximum. This could be going like this, so this could be the maximum. Or it could be going like this. This could be the minimum. But what you do know is that it's a quadratic. It's a positive quadratic. Positive quadratics are always U-shaped. And if you forget that in your exam, there's still another way. Just sub in any value for x. So if x is 0, sub in x is 0. Y would be 7, way up here. If x is 10, what would y be? 100, 200, minus 40, so it's still going to be way up here. So you know it's going to be somewhat like this shape, meaning this will be the lowest. So this is going to be the minimum turning point. That's how you find and classify the turning points. Hope this helps. Thanks for watching.